Hello students, today we are solving a question on system of particles and rotation from 22nd January shift 1 of JEE Mains 2026. The question says, a solid sphere of mass 5 kg and radius 10 cm is kept in contact with another solid sphere of mass 10 kg and radius 20 cm. The moment of inertia of the pair of spheres about the tangent axis passing through the point of contact is dash kg meter square. So we need to determine the moment of inertia about the tangent axis passing through the point of contact. Always the axis of rotation is very important. So I have drawn a diagram over here. The two spheres M1 and M2 and their radii are 20 cm and 10 cm respectively. Now the axis about which we need to calculate moment of inertia is x. Now see, you can see it is not passing through either of the sphere's center of mass. So clearly, to find the moment of inertia about axis x, we'll have to apply the parallel axis theorem. What does parallel axis theorem says? It says I, the moment of inertia about any axis, is equal to IC, moment of inertia about the axis passing through center of mass, plus md square, where d is the perpendicular distance between our axis and the centroidal axis. Here our axis is x and the centroidal axis are z and y for the two spheres. So the moment of inertia of the system will be I1x plus I2x, moment of inertia of first sphere about x-axis and moment of inertia of the second sphere about x-axis. We are adding them because moment of inertia is a scalar. Now I1x by parallel axis theorem, for the first sphere z is the centroidal axis. So I1x can be written as I1z plus m1 d1 square. Similarly, for the second sphere about x-axis, if we apply parallel axis theorem, I2y will be the centroidal axis plus m2 d2 square. This also is obtained from parallel axis theorem. So now we will just write the value. The moment of inertia of a solid sphere about its centroidal axis is 2 by 5 mr square. So substituting that, and d1 is basically equal to r1. We can check it out from the diagram. d1 is nothing but the radius of the first sphere and d2 is the radius of the second sphere. So putting the value of d1 and d2 as r1 and r2, we will end up with the final moment of inertia as 7 by 5 m1 r1 square plus 7 by 5 m2 r2 square. Substituting the value of m1 as 10 kg and r1 as 0.2 meter. Similarly, m2 as 5 kg and r2 as 0.1 meter. We can calculate the moment of inertia, which comes out to be 0.63 kg meter square.